Hello, Introductory Robotics. Welcome to part 2, looking at some of the basics of Arduino, your Hello World, Hello World part 2. Last time we talked about an LED and how we used a digital write, which means an on or an off signal going out of the Arduino to turn the LED on and off. Now, I've got a couple things open here, and I'm just going to walk you through where we are at. Right now, I've got a basic push-button circuit in Arduino, or in Tinkercad, I guess. All this does is when I push down the button, I get an LED that turns on. Normally this circuit is open, meaning it's not connected, but as soon as I push the button, I get a closed circuit, everything attaches, and I actually get electricity flowing through the LED, allowing me to turn it on. Put a resistor obviously in place so that it doesn't blow up. We talked about Ohm's law recently. That's important. The other thing I have open right now is a piece from the blog. So if you look at the blog, you actually have a DigitalReadSerial here. When you do that, you actually get to this page, which is DigitalReadSerial, and it comes with a few things you need to know. Specifically, there's a diagram of what we're going to be hooking up here today. There's also an explanation of how things work. I'll explain all of these. There's also an electrical schematic. This shows the Arduino itself, 5 volts, ground, a resistor down here. In this case, it uses a flip switch, but we're going to be using a momentary push button, which is almost the same part, slightly different drawing. And it's connected into digital pin here. We'll talk about how all this works in a little bit. It also talks about the pieces of code. So if there's any piece of this that doesn't make sense and you want to read it instead, please feel free. Part of the reason we're doing this is we're actually going to go ahead and grab all of the code that's here. We're going to copy it. We're going to head back to our Tinkercad. Notice that I already have the Arduino reference open. I'm going to be referencing this a couple times during this conversation just to give you some places to do some further reading. In Tinkercad, we've got this circuit. From here, we're going to stop our simulation. We're going to go up to our code, and we're actually going to copy and paste this code in. Now, I've already got it in place here. I was playing with this a little bit earlier, but you do need to copy over any prior code that's in there. If you have multiple loops or multiple setups in your code, it's going to send you an error. It won't work. So right now, I can see I've got one setup, I've got one loop, and yes, I'm going to zoom in on this in just a second so you can all see it. But what I need to know about this is that this is an entirely different code from what I had prior when we were looking at the LED. So let's break this code down. I hope I have it large enough that people can see it. What we're going to do is we're going to go through a few pieces. First part is lines 1 to 9 actually have some comments. It says DigitalReadSerial reads a digital input on pin 2, prints the results to the serial monitor. That's something that is really important at the start of your code, is knowing exactly what we're hooking up. It also shows the website address, the URL, for where to actually find some more information about this, which is awesome. This example code is in the public domain, which means that anybody can use it. We plan on using it today, but you could integrate it into your other existing pieces of code if you wanted to. That being said, we have this piece here is all orange because it's commented out. It has a / and a star, and at the end it has another / // and that means that everything in between those two symbols is going to be commented out. And that's important because before we talked about the idea of these double slashes commenting something out. That works for everything to the right of that symbol. And we can actually see an example of this near the bottom of this code, which is super cool, on line 28, where we actually have 2 slashes here. We have a comment, but we also have working text on this line. And that means that this text, this here, the delay, will actually run normally. It'll do exactly what it's supposed to do. And then the comment here is just for the human element. Again, that is just for the programmer. It doesn't do anything for your Arduino. It just lets you know what the person was thinking when they wrote it, which is very important. Now let's break down our code. Because the very first thing we see in our code is, on line 12, we see int push button equals 2. Now let's break each piece of this code down because this is what we would call a global variable declaration. Global because it doesn't happen inside the setup and it doesn't happen inside the loop. It happens outside of both. That means that this variable here, this push button, is going to exist for this entire code. But what the heck's a variable? Let's talk about that for a second. In this code, when we create a variable, in this case an integer variable, we are creating a bucket. And we're going to put a piece of tape on that bucket that says push button. We're going to name it so that the Arduino can easily find that bucket. And that bucket is going to have stuff in it. In this case, it's going to have a number. And variables come in different forms. In this case, we've got one where we're going to hold a variable that's not, or a number that's not going to change. We could call this a constant variable, which is a bit of an oxymoron, but still it works. It's going to be constantly the same number throughout the code, but we can also create variables that change throughout the code. Let's say we're reading a sensor and we want to see what's on that sensor and put it in the bucket so we can look at that information later and let the Arduino use it. That's what variables are good for. Now let's break down a couple things about this. INT. This actually stands for integer. And if we go to our Arduino reference and look at data types, we can see that there are actually a bunch of different kinds of buckets. There's different kinds of variables here. Integer is one of them, and it's the one that we are going to use most often. Now, if we do the reading into this, we realize that the integer is going to be a number between negative 32,000 and positive 32,000, approximately. We are never going to come even close to that. And even though that's a relatively small number in computer terms, we won't need anything like that. We realistically, if we're talking about pins, are going to need numbers between 0 and approximately 20, 19 to 20. This is going to let us store that data. And in this case, the data we've stored is the number 2, because we are going to take this bucket, we're going to name it Pushbutton, we're going to make it equal to the number 2. That simply means that we create the bucket, we take the number 2, we drop it inside. That's all we're doing right now. And what's going to happen here is that this push button is going to be used throughout the code. Now in this code, push button shows up twice. It shows up on line 19 and it shows up on line 25. That's cute. That's wonderful. We could probably just change those both times if we wanted to just put the number 2 in there and we wanted to move our push button to number 5 maybe. But the key here is that if this code is not 29 lines long and instead is 500 lines long, we probably don't want to go in and change every instance of the number 2 in the entire code. That's confusing and inefficient. So we put it at the top to make sure that we've clarified, basically we've declared what our pins are going to be right off the bat. Now from here, we're going to name this push button, and there's one last thing you need to know. Push button is all one word. It's pushed together. You can use underscores when naming variables, but you can't use spaces. You also should start with a lowercase letter, ideally, and if you have multiple words, such as we do here with push button, we're going to use what's called camel case. Camel case is going to let us use a capital letter for the second word, in this case push button, and it's going to let us use multiple words so it's easier to communicate. From here, we go down into our setup, and in our setup, we've got a couple of commands that you haven't seen yet. So let's break this down. The first on line 17 is serial.begin 9600. This simply means that we're telling the Arduino to talk to us via the computer's serial monitor. It exists down here. The serial monitor is very simply a place where the Arduino can send information back to the Arduino. The 9600 is how fast it's talking to the computer. In Tinkercad, you're always going to make this 9600. In real life, you have a few more options, but we usually default to 9600 for most beginner projects. By the time you want to go out of that mold, you will know enough to go out of that mold. The next thing we do is we create a pin mode command, and we remember this from the last lesson. We then want to designate which pin number we're going to use. Now, in this case, I want to put the number 2 here, but instead I've put the word push button, because remember, push button is the bucket holding the number 2. So the Arduino gets to this part, it goes, okay, what's in the bucket? Number 2? Great, we're going to send this data to number 2. And in this case, the data that it's sending is the idea that it's going to set that button, number 2, onto be an input. Input means it's expecting to have voltage come in. It's expecting something to act as a sensor instead of having something act as an output and send voltage out like a motor or an LED. That's our setup. Now let's roll down to our loop. This is where the real exciting stuff happens. In this case, we have line 25, which is basically the core of all of this code in our code right now. In this case, we create a variable. Now you notice that this variable is not up here at the top of the code. It is not a global variable. It is a local variable, which means that this variable here, button state, which is an integer, will only work inside the loop. It'll only work right here. Now, that's just as well because it only ever gets used in here. So we can keep that and we can make that work, absolutely. We're going to create this variable called button state, and we're going to immediately make it equal to something. And that equal to is going to be a digital read. Now remember, digital write was us sending voltage out. It was actually us sending a voltage signal to turn an LED on or off. In this case, digital read is going to say, is that pin on or is that pin off? If it's on, it's going to return the number 1. If it's off, it's going to return the number 0. Remember, digital is always on or off, 0 or 1, high or low. So in this case, we're going to digital read push button. We're going to say, is the push button on or is the push button off? If it's off, we're going to get 0. If it's on, we're going to get 1. Easy as that. Then we're going to do what's called a serial print. Serial, capital S, dot print ln. That means new line. And we're going to print whatever button state is. And literally, the Arduino is going to take that bucket called button state, and it's going to say, what number's in there? Is it a 0 or a 1? And it's going to print it to the serial monitor down here. That's going to give us some data that we can actually work with. So let's break this down. Let's go back to Arduino and let's have some fun with this. So we know that we've got a push button. We know that we've got pin 2 here though. So let's have some fun with this. I'm going to take pin 2 and I'm going to connect it to the negative power rail. I'm a big fan of straight 90-degree angle lines here, so we're going to straighten that out. Awesome. And we're going to start our simulation. Now, what we should expect from this, because we know that what we've got here is some code that, I'm going to zoom out a little bit, we've got some code here that is going to actually see what's happening on pin 2. Right now it's receiving a negative voltage. It should receive 0 volts. It should be recognized as ground. So our serial monitor, rightly, should equal 0. But if we stop our simulation and we change this and move this wire down, very simply, to the positive or 5 volts voltage level, we should now be able to start the simulation, and that should turn to 1. 5 volts 1, 0 volts 0. And that kind of makes sense, because this will let us actually turn the physical world, a push button in this case, into computer data, which is the core of everything you do with technology pretty much day in and day out in the year 2020. But let's break this down how we're going to work on this with a button. It would be easy enough to simply say, well, let's connect this, pin 2, to the back of this push button. Would this work? In real life, it kind of works. In Tinkercad, it doesn't, and rightly so. Because in real life, this is actually prone to picking up a whole lot of stuff, a lot of static. So we're going to re-engineer it to use what's called a pull-up resistor, or pull-down resistor. And what we're going to do is we're going to actually delete the LED, because we don't really need the LED now that we can read the push button straight from our Arduino. We're going to delete everything. We're going to take this push button, and we are going to connect the one side of it to pin 2. And that kind of makes sense. That's going to let us read some voltage. We're then going to turn around, and we're going to connect the other side of it to 5 volts. Right here. Make that wire red. We're going to start our simulation. Okay? Now, theoretically, every time we push this button, we should get a 1, but we're not. And that's super weird. So how do we fix it? What's happening right now is that this wire is actually probably catching some static voltage, or it's seeing maybe the last piece of data it got. We need to forcibly ground it and make it so that normally it reads a 0. And how we're going to do that is we're going to connect this far side of the push button to ground. But we're going to do it through a resistor. That way we actually are going to split the voltage here a little bit, and we'll have a little more on that later. But basically what I'm going to do is I'm going to connect a really big resistor, in this case 10,000 ohms, to the far side of the push button. Now notice that this terminal strip here and this terminal strip here are actually electrically connected. So if I really wanted to, I could actually do this just as easily. It will have the same effect. I'm going to connect this big resistor to negative, or ground. What this is going to do now is normally, when this button is not pushed, pin 2 is going to receive all of its voltage coming from negative. It's going to consider itself grounded, or at 0 volts. Then, when we push this push button, the voltage is going to flow through the push button. Because it's connected to ground here, we're going to get voltage moving through this circuit, big time. But what's going to happen is most of that voltage, and specifically the amperage associated with it, is actually going to go through the digital pin instead of ground because of this big resistor in the way. That voltage would rather travel through the path of least resistance, which literally is this green wire right here. So let's try this again and see what happens with this resistor. Right now I'm receiving 0, which is exactly what we expected. We expected this to be 0 because it's connected to ground, but as soon as we push this button, we get the number 1 running through our serial monitor, and that's because we now have voltage traveling from 5 volts through the digital pin. It comes through 5 volts through the digital pin. Yes, some of the voltage is going through the negative lead here, but because it's such a large resistor, it's a small amount, and we actually get a really good read on this. This is much more stable than our previous version, which in real life would have functioned sort of, but it would have had a lot of noise or excess electricity floating around it. Now you've got the tools for all of this. This is the key to everything that we do in terms of turning physical energy or physical manipulation of electronics into computer data, which is how your phone works, which is how your technology works, which is how our modern world works. Very cool. Stay tuned for the next one.